All right, thank you. Well, it's the last talk of the last day, so thank you for sticking around for the presentation. Firstly, thanks for attending. I know that folks probably have flights out, and you're probably tired, and so I do appreciate you sort of coming in and listening to me talk. It also means that I have no time limit, and so you may be here for quite a long time learning about DevSecOps and Web3. So I hope that this talk is at least entertaining as your last one, and that it teaches you something. I've included almost every buzzword I could find, but we've already heard the ChatGPT talk, so we're moving right along. First, a bit about me. My name is Ken Toler. I'm a security consultant at Kudelski Security. I manage the blockchain and application security teams there. I wear a lot of hats, like I'm sure many of you do. But before that, I've done a lot of work in Web 1 through Web 3. I've managed accounts. I've broken a ton of applications in startups, in governments, in financial institutions, written some blogs. I've trained some folks in Burp Suite, dynamic analysis. I've done a few talks at a few conferences. I've headed a security team at a small fintech company. Started a podcast about DevSecOps, relating to DevSecOps. My co-host is in the audience today with Mike McCabe, which is entering our third year now. And I manage a team of consultants doing amazing work in blockchain and application security. We have quite a lot of information to get through today, so I will try to keep things brief. But really, I want to just define a few things, Web3 and DevSecOps, and the way that I see it, as it sort of manifests in our world today. Give you a history of software development life cycles. I think it's important to go back into history a little bit, especially when we're talking about the topic of Web3. I want to talk a little bit about the hardship of Web3 security and sort of why we're there, some fears, failures, and wins. We'll talk about Web3 versus traditional SDLCs. We will talk about DevSecOps in Web3, and then I will get into some examples and technical references. So how many here work in or are familiar with Web3 and or blockchain/cryptocurrency? All right. And of those people that are, how many of you have written, experimented with, or analyzed a smart contract for security? Just a couple. And how many of you have done that in a language that's not Solidity or on the Ethereum blockchain? So I've been very, very, very fortunate enough to do a lot of work with kind of novel blockchains and smart contracts that are not written in Solidity, mostly in Rust or some novel ecosystems. And I think that that's what highlights a lot of these problems. So what is Web3? So I think we'll talk a little bit about cryptocurrency, but I want to differentiate between all of the things that make up Web3 and cryptocurrency as its own thing by itself, because while they're absolutely related, and they're very important to each other, cryptocurrency is really just one aspect of what we refer to as Web3. It enables and drives incentives that create this idea of a decentralized capability. And so with that said, I do like how Ethereum and Near define the progression from Web 1 to Web 3, because I think it relates to something that resonated with me, which is POSIX permissions. So I have a little note up there for anybody that's familiar with Linux, and hopefully that will help. But Web 1 was what some folks refer to as the read-only web. It was what some of us, I guess older folks, think of as a server-to-client relationship. Organizations would host their sites and consumers would largely go to those sites for information, and there was this limited interactivity. And even though we had email, and you can argue that there were peer-to-peer networks, the mass adoption of Web 1 was largely read. And as we progressed into Web 2, we start to see things like software as a service become a thing. You begin to see the rise of social networking, and we saw the interaction of people on the web. And the peer-to-peer adoption became more and more mainstream as we went along, and we saw the acceptance of things like that were faux pas, like online dating, social networks, media in your pocket, shorter sort of attention span driven things. And this progression has been where we are today. But even though we're all interacting with each other, it's always been through this third party, whether that's a company, a cloud service provider, or some other entity that we pass our information through. And we see this concept even in some of the cloud security models that we've seen. If you've seen any of the talks that we've done on sort of chaos in the cloud, we have these shared responsibility models that try to break up, who's responsible and accountable for what, and what are we claiming accountability and responsibility for. In Web3, amongst all of the buzzwords and hype, this idea of ownership always comes into play. It's this true ownership of that information and capabilities without this involvement of a third party that is starting to set it apart from Web 2. That idea of ownership supported with this underlying foundation of what we would consider now to be Web 2 technology, and that progression from Web 2 to Web 3 is what creates this attractiveness and hype and excitement around Web 3 as a concept. And so if we think beyond this idea of read, write, and ownership of the web, it's really what starts to unpack this dream that people are after, and maybe even what the hype around Web 3 is. And I think that this is my NFT, by the way, just because if we've got to talk about it, I got to purchase something. So we have this real opportunity to create a community-owned, operated, and controlled world where these individuals can bring their digital and physical lives together. There's a belief in the community that this creates this new world that's enabled by technology. Technologies like NFTs, cryptocurrency, blockchain, AR, VR. We heard a great keynote about artificial intelligence. It brings real economies and jobs and capabilities into the real world, where something like building the greatest spaceship to travel the galaxy in a AAA game can have real world value, or it can simply grant you access to trade at levels, monetary levels, or give you access to markets that were previously only available to banking or financial institutions. You could also consider this a technology for all of the security professionals to roll their eyes at, the same way that we viewed, the cloud as someone else's computer 10 to 15 years ago. And look where we are now. Whether or not this is the future of the web or how skeptical you are is probably beyond the scope of this talk, but I just want to highlight the desire of technologists and people that use technology to move forward and maybe understand what our role as application security professionals can or will be. So I like this graphic. I sort of took this from Storyteller Tactics. I don't know if you've all looked at this, but I really like this graphic because it shows kind of where I believe Web3 is, both in adoption and in security. And to stop to understand that we're really only what we would consider entering like this early mainstream idea of Web3. People are recognizing that there's something to it, that it's interesting and exciting, but nothing's really been proven to the masses. There's still a lot of skepticism, and there's a lot of failures which create an understandable amount of skepticism, and these teams are largely fighting an uphill battle. This is the same uphill battle that social media went through. If any of you remember companies or apps like Vine, MySpace, Foursquare, Snapchat, only a few of these landed or were bought or acquired by other major players. We also saw this happen in Web 2, starting with just Gmail, Salesforce, and Amazon, and this extending into present day. I myself worked for, a Web 2 company. We were trying to tackle, G Suite. It didn't work out. We used to look at cloud as this ridiculous idea because you were willing to give information you've been trying to protect for years, to a third party. Why give up control of your assets and data to some other person? And now cloud and cloud service providers are a part of our everyday lives. And you could almost argue that we think it's ridiculous not to use cloud or leverage it in some way. If any of you attended a security conference 5 to 10 years ago, you would hear a much different message about cloud than you do today. So with blockchain and Web3, I just want to highlight that we're in the nascent stages, and I don't know when we'll see it peak into mainstream, if we ever will, but it's certainly interesting to think about as we think about this concept of bringing physical lives into the digital world. Another nice graphic to look at, which I do like, and I love it because for one particular reason, which I'll get into, but Gartner puts out these hype charts, taking different industries or elements of a different industry through specific verticals, taking it from innovation through inflation of expectations. And this is my favorite set of words on any professional chart, and it's the trough of disillusionment and out into this plateau of productivity. And I like the trough of disillusionment because for security professionals, it's super interesting. With cloud, you can see that cloud platforms have solidified on the far right here, and some new cloud ideas like confidential computing are still nascent. And with Web3 and blockchain, nothing is occupying the productive space for Gartner. And the majority is in this inflated expectations realm, which I would probably agree with, the most mature being cryptocurrencies, decentralized applications, and blockchain. I would say security professionals often get into the trough of disillusionment early, and then we sit there for a while the world moves around us. And we hang out there and we kind of wait for the slope of enlightenment to solidify, and then we sort of hop on the bandwagon again. Now, the next buzzword that I want to unpack is one of my absolute favorites. That's DevSecOps. There's a whole track right here dedicated to this one word. And I think it's pretty controversial, or, we don't always agree on the same definitions, even in security circles. In fact, one of my favorite things to ask people is, what does DevSecOps mean to you? And I find it fascinating to hear what drives people into the world of DevSecOps and why they like DevSecOps and why you all are here, listening to this talk about DevSecOps and Web3. Some people will talk about secure DevOps, security automation, shifting left, maybe just reference, this weird thing, which we're still trying to figure out. But for me, I think of DevSecOps as a method, right? Composed of these three pillars that drive decisions in application security. I really look at DevSecOps as a mindset. We really internalize that we want to fit security into every phase of the SDLC and get beyond using it as like, yes, I'm just going to take a product and put it in every phase of the SDLC. We want to do that while maintaining and enabling the speed and efficiency of the development team. And that last part is really important because it means that security is a first-class citizen to the business in DevSecOps, but it also means that engineers and software developers are first-class citizens to security. And that brings us into collaboration, which means that we need to consider the developers and engineers that we need to include in development teams as part of every aspect of the business product. And in order to do that, we have to really think about more than even engineers and think about everyone that influences or cares about the direction of that product. That means your product managers, your project managers, designers, legal. I can't tell you how many times you go into a threat modeling session and you start to talk to UI designers, and that starts to unpack some of the easier sort of threats that you're going to see when you start to look at, oh, well, they want to do that in the UI, because that's super, super early in the design process. And then lastly, and only lastly, does automation come into play. And automation to me is not the most important aspect of DevSecOps. It's really the softer side of it, right? But it is really important because the key is to automate things at work. If you're automating your DAST and SAST scans that you were running 5 years ago and they're taking an hour, we just heard this whole talk about SemGrep and speeding that up. You're probably doing it wrong. We're not bolting security on. We're adapting and enhancing the security within the SDLC based on the advent of new technologies, which Web3 really, brings to bear. And just to drive this point home, I want to take a walk down memory lane around the evolution of development frameworks and methodologies, because to understand where we are in Web3 and why we're in the situation that we are with Web3 development, it's important to understand sort of what drives change in the methodologies that we use or the frameworks that we use to develop software. So you might recognize this as the waterfall methodology, sort of the chilled out, slow, methodical, nice and easy way of developing software. And I don't need to explain all the deficiencies in this. There are some folks that still use waterfall, but we've largely moved beyond that. And so, we wanted to move faster. So we figured out Agile. So we've got a sprint, we got 2 week, 4 week sprints. Some of you might use the scaled Agile framework. You've got your portfolio planning sessions. You're spending some time talking to each other. You're moving even faster. And maybe you're a bit more flexible. You got more input. You have some flexibility. So then you're like, all right, well, let's get some more people involved. Let's add Scrum. Now we're really moving. We've got multiple inputs from multiple people. You got our Scrum Master doing things, dealing with all of the engineering folks. You got the product owner. They're getting user stories in. We've got devs. We're sort of adding this stuff on. We can even move faster. But then Jeff Goldblum comes along. You got to get away from the T-Rex, right? You can move even faster. You got to beat the competition. Now we're getting into things like Kanban, where people are literally ripping Post-its off the wall and then going and sort of, developing things just as they see fit, sort of unlocking this unbridled power and speed. Security's trying to keep up. We are, now moving into, the infinity war here. You've got DevOps, Kanban, automation, CI/CD. Machines are developing first now. You've got ChatGPT and Copilot. You've got AI. We are really trying to keep up with all of the tools, again, the technologies that are assisting with this next evolution of the web. And who knows how much faster we can go if we have this sort of machine-assisted coding and the next generation of technology. But developers and software engineers are moving faster than ever, and much faster than we ever have before. Many of the talks today are really focused on how we can keep up with the speed. And our approach is always something like, well, we can put some security on top of it, and we find ourselves using the same tools, maybe ramping up the performance of CPU power or trying to tweak the performance of the tools and doing them in different ways. And this isn't all the tools that we have, but the large number is really just trying to take what we do and ramp it up to supplement the people that we have. And we haven't really internalized this idea of integrating security into every phase of the SDLC. Instead, we're taking our tools and trying to push them on top of every phase of the SDLC. And I've seen a large number of clients trying to sort of shoehorn existing DAST, whether that's driven by budget, existing SAST, sticking around in pen testing. And so we really never move past this testing phase and this review phase, the pen testing and getting right past that, those two areas on the sort of right side. We talk about shifting left and threat modeling, and it's very difficult to line that up with the speed. Sometimes they never get past that. I've seen clients that have been doing this type of work for 10 years, and they really just kind of are stuck on those last three phases of the SDLC. And that brings me really to one of the most important things about Web3, and that's that they oftentimes use none of these frameworks. Most of the time, especially when we're talking about public blockchain development, and I'm not necessarily talking about corporate blockchains or internal blockchains, they probably operate mostly like Kanban, where they're sort of taking issues off of the GitHub queue and submitting pull requests, but it's really not defined. It's because there are entire organizations made up of distributed, decentralized teams that just pick tasks up off of a board, put the code into the product, and deliver them. And oftentimes these teams are really small. In fact, if I were to tell you that I've worked with an organization that managed over $60 billion in trading volume of decentralized currency on an exchange, how many people do you think make up that entire organization? $60 billion. Anybody want to venture a guess? What is it? It was 5 people. So if you have 5 people managing $60 billion, that's a good guess. You work there? No. It's kind of mind-boggling to think about the amount of teams. And then we say, well, you need to hire a security person. They're like, that's a large amount of my budget, a large amount of my team. And so they end up in a position, kind of like open source, where community drives feature requests and there's some informal discussion within a small team. And they're able to move faster than any of the development teams that I've seen, at least aside from some of the most mature. And that really does obviously come at a cost of security. In some cases, which for the most part is really limited to audits and of their smart contracts, which they consider the most critical portions of their product. And for a large majority of these groups and organizations, they really do care about security. They just aren't armed with the ability to execute on security. Many of the security bugs that are discovered in the audits, if you think about like how much they are committed to it, are fixed in the same day. We've seen, in the news and know from our own histories that just auditing one piece of code really isn't going to cut the mustard, but we really need to figure out how to allow these folks to develop at the speed that they develop, and help them secure the product. And that is key because a lot of these folks have moved on from sort of other organizations. So with that in mind, I was thinking, how do we distinguish the mindset of a sort of traditional software development where we've been building and building and building with Web3 software development, at least as I've seen. I've said, this is kind of a consolidation of maybe 30 or 40 different organizations or teams, 5 or 6 people teams. And that's these SDLC personalities. And I want to highlight some of the points as it pertains to speed and quality and security in the code. So in traditional development, we're pretty methodical, even if there's some chaos here and there when we're fast. We tend to pick up the elements of frameworks and methodologies that suit us, analyze the needs of our customers, and methodically move through a comprehensive approach or try to attach some approach so that we can iterate at these small intervals, Agile, Kanban, and then we regroup often. We try to introduce security at every phase through process and tools and technology and people. And then we've ended up at this reasonably fast, or what we consider reasonably fast SDLC that is mostly organization driven, either by product managers or executives. And we're mostly reactive. I know that folks are starting to get more into and using threat modeling and sort of shifting left, but we're mostly reactive. There are some exceptions. But in Web3, and this is by no means all of Web3. I'm speaking somewhat in extremes here because there are Web3 organizations that sort of play in both worlds, right? They're Web2 converted to Web3, or they're adding blockchain to their workloads. Because there's organizations in that are hybrid, that have this infrastructure where they will build, and we'll get into the threat modeling a little bit later about sort of where that all fits. So they code as fast as possible. They peer review heavily, very much about peer reviews. They establish requirements actually using feedback from their community, very much like open source. And they rely heavily on a security audit from what they would consider an established firm whose reputation is sort of provided through the community, right? Whether that's like in Slack channels or in Telegram or something else, you gain this reputation for being able to deliver a good audit. And that's how they know to use this particular one. It's incredibly fast, again, reasonably secure, at least as they see it, and mostly community driven. So the primary issue here is expertise in security, and many of the auditors are only auditing the contract portion of the code because that's all that's purchased. And as we've seen in the news, and as we'll see in the threat modeling section later, it's only a small part of the whole product. So as I was thinking about these, I couldn't help but think about Batman and Spider-Man, because any comic fans out there, Marvel, DC, we got some competition. All right, that'll make this will probably the rest of this is going to make this most sense to you. Everyone else will probably be lost. The point I want to make here is that no matter which camp you're in, DC, Marvel, Batman, Spider-Man, Web3 or traditional, all of us are trying to be the same kind of hero, and we do things a bit differently. But at the end of the day, our goal is pretty much the same. Important thing is to recognize sort of where the other side is coming from, and get back to our spirit of collaboration and figure out how we can leverage each other to move forward. So Spider-Man or Web3 is all about much web as possible, leaning into new technologies. They understand that old software development was slow and want to adopt and move into like, what is the next thing? And just like many of us are excited about, we're excited about cloud back in the day as the new thing. They believe that speed is their greatest defense, that moving fast, recovering fast, having flexibility and faith in the community will help weather the storm. This is why you see a lot of these hacks and breaches get recovered by the community. They prioritize security, but they aren't necessarily funded with the ability and to add security, and it cannot be at the expense of speed. So all of these old school things that we talk about when we bring up terms like Stride or SAST or DAST or even DevSecOps, they don't make sense to them. They need to find meaning in that functionality because a lot of them come from bad experiences with those worlds. On the other side, traditional folks or even folks that are coming to join the workforce maybe 5 to 10 years ago, we've seen some things. We've had great failures. We've broken production. We've lost money. We've had failed startups. We've gone down the cloud path, and we've learned how immature and new technology can fail horribly and unrecoverably. We've seen the public S3 bucket hacks. We've seen open Redis instances and open cloud databases and things like that. And so as a result of those failures and learning from those mistakes, that traditional mindset sort of thinks before they leap. They investigate very heavily before they're acting. They believe in speed through consistency and not just sort of pushing forward. So a lot of times, we build capabilities sometimes in a silo to try to solve the problems that we've seen and try to fix the problems at scale rather than just jump headfirst into incomplete solutions. But the unfortunate part for us is we don't control the narrative, right? We're not the money makers. So as a direct result of these approaches, Web3 gains unparalleled speed. They can achieve what they would consider quality through peer reviews from sometimes an unlimited set of eyes. They're able to treat security as what they would consider a first-class citizen and receive input from otherwise untapped resources because they're leveraging an open community. They're very early in adoption. The community is largely technically capable, meaning that a lot of the things that they're talking about within the context of their community, other folks in that community understand. And they have this incredible adaptability and flexibility. They're able to achieve massive change in under 24 hours. Unlike the majority of open source, they're actually compensated well and incentivized for these efforts through cryptocurrency. So on the traditional side, in our more mature cases, that we have other benefits, right? We give measurable KPIs and methods to show that we can quantify progress and the path of security. We have a breadth of coverage and security from operational, informational, physical, and others that Web3 doesn't necessarily always have time to focus on. They're largely distributed teams. They don't necessarily think about operations. There's this tremendous consideration for like looking at an organization or a product with a full scope. well beyond application security. And there's readily available training and staff for it. It allows us to focus on, specialization on security verticals and development of skills in particular areas that eliminates like this split and focus that a lot of these Web3 organizations are going through, where they have 5 people that need to do everything in the company. So obviously both of these approaches have their benefits, and they can result in some serious deficiencies. In Web3, we commonly see vulnerable code being pushed by non-employees or open source contributors, and that's what seems, that's similar to what you might see in open source. But with this world, in crypto, there's some very real motivation for attackers to actually want to compromise these projects. And that's just cold hard cash, right? If they can get some crypto out of this, that's something that they can turn into immediate value. There's a heavy, almost unreasonable reliance on the community for code quality and also for security. There's this lack of consistency or documentation in process. So they're sort of almost, they can be sometimes processed void. There's not really a lot of documentation necessarily around architecture or how things fit outside of what might be found in a repository itself. And so that can kind of result in a more extreme sprawl of internal tools, doing redundant things or like inefficiencies that are hidden by this speed. So, the things that we always see where it's like, well, maybe we have 2 tools that do the same thing, or everyone wants to use one kind of tool. You see that happen a lot more in these distributed sort of remote teams where folks will spin up a SaaS product operationally, kind of manage themselves in that, and then bring it over into what would be considered, I guess, a corporate or an organizational product. And so with the amount of players in this space, and given that it's still nascent, and the ecosystems that are in the market, there's a really severe lack of tooling and standards. Ethereum, Bitcoin, corporate blockchains, some of the ones that are more well adopted are much further along in this respect. They have sort of coding standards, common attacks, common weaknesses. But there's a number of other blockchains that are written in Rust. They have different SDKs that you would use to deploy contracts they have different security considerations or different ways of operating that you could probably relate to most like a web application framework or something along those lines. And those concepts can be kind of hard to keep up with, especially if you're starting at zero. On the traditional side, we're often handcuffed by process and standards, especially when it comes to compliance, which, if we all know if you approach that with sort of this checkbox mindset, that can really result in a false sense of security. And I think that a lot of folks that have converted over to these Web3 organizations really are bristle at the idea of compliance because of that. The way that we handle security budgets can often result in shelfware or incompletely implemented tools, a lack of focus on maybe some of the more specific problems like how data security is handled in application security, or is the IAM policy aligned with our application single sign-on? There's sort of that split where we see application security become isolated from the rest of the security policy and process. And then, we can just kind of grow complacent. We find something that works, that the board likes to see, and we kind of, churn along on that. And I think that just like Spider-Man here, overloaded with all these tools and gadgets and bags and utility belt that Batman uses, there's this fear in Web3 development that security is this world of no, and that these old tools and scans and methods and requirements will slow them down severely. And they're not necessarily wrong. Many of these developers either hear the stories from enterprise days or are converting from enterprise to sort of feel this power of distributed teams and Web3. And lastly, I think there's just this general fear that people and practitioners just don't get Web3 or don't get blockchain or, aren't part of the community that they love so much. And these ways of thinking, this corporate way of thinking, doesn't incorporate the excitement of this new technology. And without that understanding, these traditional methods are just going to sort of neuter process and stop it all together for them. And so they rely on audits of only a trusted few, and they place a tremendous amount of faith on a point-in-time reference in an audit. And it's almost like these source code audits have become the new compliance. On the other side of the fence, I have very sad Batman with no costume and no utility belt. And we feel like, if we're looking at Web3 from this perspective, we feel like there's a lack of control. There's ignorance of those that came before. We don't want to see another progression of technology fail. We kind of roll our eyes at every hack that we see every sort of couple weeks, seemingly every month, thinking that this is a repeat of history, right? This is cloud all over again. This is Web2 all over again. Now, lack of control and understanding is, it's just someone else's computer. That mantra that we've said over and over again. We're kind of afraid of these rogue developers that just want to ignore security and lacking tools and defenses without proper investigation, and feel that all of this is moving without this foundation and fundamentals and without this like legitimate secure development practice. So what I want you to take away from this is, Web3 is our lesson in security that software developers and software development will move on without us. And if we don't change our perspective on security, we'll never catch up. We're all striving to make security a part of every phase of the SDLC, and we want the same things, but with small budgets and smaller staff and a role that doesn't generate revenue, we really have to work on enabling engineers. The way we catch up is by finding ways to move at the same speed as our engineering teams rather than forcing them to slow down. Otherwise, we're just going to continue to repeat history and become that new reactive audit team of 2023, because now we're doing code reviews instead of compliance audits. Now, DevSecOps provides us with a methodology to do that. And it's by taking time to understand what developers and engineers are going to need to sort of be successful in using our knowledge to help them kind of stay fast. So if your design process is 4 hours, you kind of think, what can I threat model in 4 hours? If it doesn't, fit, how can I make this function move out of band? If your scan time is 4 days, how long is your final deployment? I think that we've seen this theme happen, through the last few talks on this track. And one of our biggest successes, and I say our, at Kudelski, is working with clients in formalizing the information gathering process of the audit and using that as a way to threat model these applications. We're doing this through small increments, or working directly with engineers to write tests. We spend a lot of time asking developers what they want, because these are development first organizations, so you need to be able to consider what they do. And with that, we've been able to successfully make almost these micro steps in the right direction and gain faith and favor through capability and the ability to deliver these things on the micro level that allows us to sort of present the meat of what we kind of hide in the buzzwords of DevSecOps and all of this. So you're probably asking now, if you haven't been for the last 10 slides or so, how can we achieve these goals? And what can if I go and find a Web3 engagement tomorrow, what can I do that will help sort of facilitate this DevSecOps mindset? And I've seen the most successes in these few areas that you can implement and talk about almost immediately that go beyond reviewing code or conducting a pen test, which you'll almost always do. So I know that we're going to get into some of the technical examples, so I'll stop for just a second. Are there any questions about sort of this piece of the presentation? And then we'll jump right into sort of showing you some of the use cases or real world cases that we've gotten so far. All right. Okay. All right. I'll also have another question answered after that. We're going to threat model with Batman. So I'll go through all these high-level examples, but when thinking through it, I think it's important to consider that in implementing all these security practices, you're internalizing that you're focusing on the developer enablement over controlling the engineering team. You're embracing the technology that you have available to you, adapting your processes for speed and flexibility and enhancing those capabilities. So this is an example. Let's see if this will play. What's happening in the bottom right here? Anybody play Dungeons and Dragons? Anybody? Okay, a couple people. So I'm a DM. I have, and I like to roll dice. And so I've created this small smart contract to roll dice. And this is just going through what connecting to and using that application might look like. And on the model here is sort of this contrived example of what an application like this might look like. And so you'll see that, I'll connect my wallet and I'll sort of go in here and I can roll some dice. And what I want you to understand is that even though this is on the blockchain, one of the things that we need to consider is sort of what is the next paradigm shift of how blockchain has, or how applications have evolved. And a digital application, or a DApp, is what this is, and it runs on a peer-to-peer network, the blockchain, and it's most commonly accomplished through a smart contract on the back end, which we'll get to sort of in the code review portion. And both of these store data and execute logic on what is basically a shared computer of the blockchain. And under that, within the ecosystem here, you can kind of see the progression of underlying technology for all the things that make up a DApp. Typically, there is some cloud infrastructure represented sort of in this example by RDS and EC2 and EBS. Those might do things like some of the storage that doesn't need to be done on the blockchain. On top of that, there's maybe an application layer, which uses some Web2 assets. Like maybe you need to have the metadata or the pictures, or not the metadata, but the pictures for your NFTs, what the actual contract references. Or maybe there's a front end in React, like you see here on the dice roller, that interacts with third-party services that maybe you don't need a chain, or these Oracle services that you might hear about. And finally, you have the contracts. And most maximalists, or folks that are very much Web3 focused or Web3 first, it will tell you that they're putting everything on the blockchain. But I think that this is probably going to be about as common as cloud native applications that you have today. Those folks that are starting in the world of smart contracts and Web3 are probably going to be more likely to have all blockchain applications. But more than likely, you're going to have this hybrid environment, something like this. And the one thing you might that you probably want to be aware of is that the user is typically interacting with the blockchain through a key pair or a wallet. And they're interacting directly with the blockchain either by themselves or through instructions that are provided in some way through this front-end JavaScript application. But it isn't always the case, but you will find it a lot. You'll also notice that there are some APIs in the back end that will interact with other entities outside of that contract, or interact with a contract on behalf of the user or on behalf of the organization. Maybe they're deploying it or making a change. Maybe they're performing some sort of administrative function on the contract itself. The contracts you can kind of think of as, I like to think of them, if you're trying to sort of make a shift in your head from cloud native to Web3, think of them as Lambda functions, right? They have methods and functions that you can call, and you can almost treat them as an API, but rather than access them through an API endpoint, you're accessing them through a node on the blockchain. And when you're threat modeling, you can use the same things you always use. You can use Stride, you can use Pasta, you can use custom techniques that you've developed, you can ask questions, you can use any of your threat modeling tools. You just have to understand some of those basic concepts and kind of internalize this structure, and you can take them into information discovery. And also, if you're someone that's just like, I don't understand any of this, the contracts or anything, you can still be a player in this game just by being the person that models cloud infrastructure. I will say, don't try to boil the ocean. Don't try to go do a big threat model of all the things, because more than likely you're going to get turned down by an organization. Just start with a contract, or even with the cloud infrastructure, and see how that lands, and then iterate from there. That's kind of how I would like folks to think about threat modeling and how it fits into DevSecOps, is this iterative process that fits the design process or the requirements process. So here's an actual example of based on a real engagement. Obviously, a lot of this has been changed. The architecture has been changed, renamed, re-architected a little bit to protect the innocent. But one thing to note here is that there's exactly two connections to contracts and to the blockchain. One is through an API where the contracts are managed and admin functions are run, and the other comes directly from the user when they interact from the browser. The rest of this model would be what we consider Web 2. It's pseudo, and so this kind of pseudo client, when they first approached us, they were looking for a contract review. So what we did is we went through some information discovery. We asked questions about where it was deployed, how they handled their SDLC, sort of questions you might ask in a maturity assessment. And we started to unlock some of this underlying infrastructure. And you'll find that most Web3 organizations do not focus on Web2 infrastructure, and you have to sort of draw that out. And there's cases where those are absolutely the weakest links. They might be the phishing attack that you hear the next month, or a bot in their Discord server, or draining the wallet of one of the DevOps admins because they forgot their computer in a coffee shop or something like that. And the most important thing I want to leave you with here is that in the spirit of DevSecOps, this threat model was many sessions that we took to sort of teach threat modeling and to also sort of threat model individual components that we then combine into a larger model for them to use. If you don't focus on that way, you'll probably get sort of, this mediocre response if you're trying to deliver this whole hog threat model. Instead, start function level, and move out from there. It not only is going to help you, but it's going to start to highlight some otherwise unseen weaknesses and risks. And you'll probably face some pushback from these sort of Web3 native folks that are like, we don't really care about the cloud infrastructure. And it's our job to sort of highlight why that's important. The next secret to success that we've found some traction in is writing tests. It's probably not the most popular, but I think I'm getting less and less pushback as time goes on. Learn to code. Even if you're operations, these organizations, they love all things code. And I'm not saying you're going to need to have a computer science degree in anything, but you absolutely will fall behind if you cannot read code in Web3. And I think that it's becoming more and more approachable, and organizations like Near make it more and more accessible to folks that haven't coded before. But you will 10x your capabilities and your ability to talk with developers if you just do a little bit of effort on the code front, understand some basics there. These contracts typically or can use incredibly simple logic, and that's built into languages like Rust and ecosystems like Near or Ethereum, allowing you to be effective pretty quickly. So just spend some effort and go through that, and I think that you'll find that you're sort of making your way there. If you don't know how to code and this doesn't make sense to you, that's okay. I'm gonna just move on to this sort of code example. Basically have two functions in the dice roller. One is to roll dice and a number of sides and return the result. So we're just going to go through an example of what you might see and how you might write a test and how you can sort of get into the flow of a smart contract and what you might see. There's a lot of problems with this code. It's mostly because I wrote the code. So, you can find a bunch here, but I have some intentional ones in there as well. Does anybody want to call out anything in this immediately? It's probably a lot simpler than you think. All right, let's watch it work. So what I'm doing is I'm calling this function on the Near blockchain. I'm specifying a contract address. I'm providing it with a set of parameters, the number of dice and my account ID, which is paying for the transaction. And you'll see that I get a result. It's 6. So that's my roll of 1d20. If I roll it again, you see I get a 3, and I have some interesting things. So I can basically take any integer and do that. But what if I put in a negative number? There's some very interesting things that happen on the blockchain, especially in Rust when it comes to signed and unsigned integers. And so if I roll something like this, I'll probably get some interesting results. Negative whatever that number is. That's not probably possible. And so I think, does anyone want to guess why this happened? Yes, exactly. There is basic, well, it's kind of an overflow. So you have your overflow. It's basically in the same realm. Because my range is 1 to -10, it actually wraps around to get to that -10. So it's going through this entire set of numbers to get to this other number. And so this is something very simple. It's a very simple attack. If I was, if this was something that I wanted to do and I'm rolling for money, this would be a very bad thing to happen. Also, you'll see that if I adjust the number of sides, because it's -2 to 6, I'm always getting 0. So when we talk about writing tests and we talk about security unit tests, this is one of the things that we almost never do, or I never see. We talk about it a lot at conferences, and I don't really see it a lot out in the wild, is actually security engineers writing tests for their developers. Blockchain and smart contracts make this incredibly easy compared to maybe some other testing suites where you might have like a Sauce Labs or something like that, because especially in Rust, it's built into the platform, and these are the things that they want to see. So if I wanted to write a simple test to say, all right, I want to test and make sure that if I roll a negative number that, I fail out, or I want to see what happens if that does happen, I can write it, and it literally is, 5 or 6 lines of code. I can specify the test and run it and include it in my developer's test suite. I'll also say that Web3 developers are very, very, very good, or at least, or for the most part, at making sure that they write tests for their functions. And you can kind of use this as a pseudo dynamic test for things you otherwise wouldn't have access to. So if I did run something like this, I might get a result like here. I would error out, and you can see that ran in 1.14 seconds. If I run the entire test suite, you'll see that I can run all of my tests in, half a second or so, and I can include that in the test suite. And you're not necessarily limited to something like just the command line. You can include this in the test suite as well. But I think the key point is, make sure that you're taking some effort to maybe write some of these tests for the team. If I wanted to fix this, I might make these unsigned integers, which would kind of error out or fail hard on an overflow, like you mentioned. That's probably not the best solution, but it would get me to sort of the next phase. Now, just to showcase like how someone might deploy this, in Near, you can upgrade smart contracts, which, for a long time, that wasn't something that we could do. Basically, once something hit the blockchain, you really couldn't upgrade it. You were kind of forced to either move it to another contract and tell all of your applications to move over, and it existed forever. With Near, we have the ability to redeploy the contract, and this is what that might look like. We start the deployment. We deploy it out. Because I'm logged in as myself, I would be able to roll the dice, and if I roll them with a negative number, because I'm now using unsigned integers, I should get a panic in the contract. So the contract panicked, failed to deserialize the input, and now we're sort of on to the next thing. And if I had that test in there, I'd know that was a potential problem early on. And if I have that test in there, obviously I'll always be able to see what happens if I put negative numbers in. All right. So just moving on to sort of the last thing that I want to talk about, and that's inventory. I think that one of the things that I always see is problems with application inventory or cloud inventory or asset inventory across the board. So this last one is by no means quick, but this is the last sort of push for the presentation. And if you're not focusing on application or asset inventory today, it's really important that you take the time to make an effort to understand what you have to protect. I think, as an application security person, the best way to think about understanding the application is really at this holistic level. And I call this sort of finding the animal names. I remember when I first started working in software, we always had like weird names for applications that didn't make sense. So I was always trying to find out like, how Tiger connected to Llama, and I didn't know what Llama did, and then Llama went to blackout, and we're trying to draw these diagrams, and they don't really make a lot of sense. And so I think it's a lot of times it starts by just asking developers what their perspective of the product is and what the associated applications are, and getting an idea of how things fit together. And you will more than likely be shocked at where some of the bodies are buried. Not only that, but you'll probably be shocked by how inaccurate the information is or how much it changes from team to team to team as you're talking to engineers and developers. I can tell you this is a real challenge in traditional development in organizations because we have a lot of applications and servers and APIs and third-party services, and there's this real lack of documentation. And I think it gets a little bit easier with cloud as you have things like CSPM or you're using tags or that you're going to be billed for things, but it's not foolproof. In the case of Web3, one thing that you can focus on if you start to look at contracts or where contracts are is the presence of contracts on the blockchain by address. So you saw the contract address that we deployed. I can look for that and I can see who owns it. And I may also be able to see any historical transactions that took place, which means that I can also see whether or not the transactions came from someplace that I expected. And that's always publicly available. So there's sort of an attacker OSINT sort of mindset that you can use there, and there's an understanding your own application that you can use there. You will always know what wallets or what entities have ever interacted with your contract. And you should also know which ones are appropriate, like who is supposed to be deploying, who's supposed to be editing this contract, who's supposed to be interacting with it. For cloud infrastructure on the Web3 side, make sure you make an effort to understand what's being built and how it all fits together. So last thing I'll go through is just some examples of how you might see deployed contracts on Chain Explorer. So if I'm using a Chain Explorer for Near, I might see that a key was added to a particular contract address. That's showing that, hey, I can call any method. So that's any update or upgrade method. And then from the wallet side, I can see any authorized applications that I have access to on the wallet side in Near. For other blockchains, such as Ethereum, you might see something like this where you can look for the contract address and see who's interacted with it. And there's some tools available like Dune that will allow you to take an owner address. So you can ask the organization, hey, like what deploys your contracts? And then you can start to see any contracts that they've deployed. So not only will you be able to get a good inventory of those applications and be able to relate them holistically to the code, but you can also make sure that you have eyes on all of the things that you should have eyes on. So I know that was a long one, But if you have any questions or you want to reach out, you can reach me on Twitter. If you want to listen to the podcast or shoot us a note, r2dso.com, and you can always reach me at work at Kudelski Security. Really appreciate you all coming and listening to me rant about Web3. If there's any questions, take them now.
Any questions? Is there actually any difference in fixing issues once they are rolled out to production compared to Web 2?
So depending on the blockchain, like I mentioned, sometimes depending on what the issue is, there can be a difference. In general, I would say it's probably just happening a lot faster. So there's not as much hoopla around fixing things. There's not a lot of process associated with it. At least what I've seen, it's kind of like you identify a vulnerability, suggest a remediation. A lot of times that can get pushed out the same day. So I would say that there's a very clean path, especially on the contract side. On the infrastructure side, there's probably nothing being done. So I would say that there's much less focus on all the cloud infrastructure and on some of the other, I guess, more operational aspects of Web3 organizations.
Any other question?
How did you manage to get those awesome Spider-Man pictures for your presentation?
Well, I mean, it wouldn't be a future of technology if I didn't use some sort of AI to generate images for the presentation, and that's exactly what I did.
Questions?
All right. Have a safe trip back to wherever you're going, and thanks for listening.